All right, so this is the compare and contrast properties of matter, which is a quiz that we just did on Thursday. So I'm going to go over and you can review this. And so the first question says a student is using a beaker and a balance to measure and compare the properties of two liquids. Each beaker has a mass of 30 grams. So the beaker is the glass, and the glass itself weighs 30 grams. So both of these are the same, so 30 and 30. But down here on the scale, it says that the scale, the beaker and the liquid inside is 44.2 grams. So in order to find out what the mass of the liquid is, we're going to take the total, 44.2, and we're going to take away this 30 right here is the beaker. And so when I subtract this, 2 minus 0 is 0, drop down that decimal, 4 and 1. So the mass of the liquid inside whatever liquid A is 14.2 grams. Over here on liquid B, the total was 45. When we take away the 30 grams, that is the beaker, we're left with 15. So 15 is the mass of liquid B. So even though these two liquids look similar, I can tell that they're different because they have different masses. However, they do have the same volume. If I look here, the amount of space that they're taking up, it's right here on this 15. And same thing over here, right at the 15. So they're both taking up the same amount of space. And this kind of reminded me of one of our examples in class where we had a ping pong ball and a golf ball. And the ping pong had the same size as the golf ball. So they both were taking up the same amount of space. They had the same volume, but they had different masses. When you hold the golf ball, you know that it's much heavier than the ping pong ball. So same thing here. These two have different masses, but they're taking up the same amount of space. All right, so then we had to come down here and we had to choose 3 correct answers or 3 correct statements. So the first one says the volume of liquid A is 15. Well, both of the volumes are 15, so that one's correct. The mass of liquid A is less than liquid B. So I'm going to go over here to where I talked about mass. The mass of liquid A is 14.2. And the mass of B is 15. So yes, 14.2 is less than 15. So that's true. Next, liquid A and liquid B are different liquids. Again, I can make that statement because I see that while they do look the same, they have different masses. So again, just because they look the same or they have the same volume like the ping pong and the golf ball doesn't mean that they're the exact same. So yes, I can make that statement. Now let me just verify that these two are incorrect. So this one says the mass of liquid A, which was the 14.2, is more than liquid B, which was 15. So is 14 more than 15? No, it is not. The volume of liquid A, which was 15, is less than the volume of liquid B, which was 15. Is 15 less than 15? No, they are the same. They have the same volumes. All right. Question 2. Here, Diego is comparing the solubility. Whenever we see this word, solubility, we're thinking about the ability of things to dissolve in another. So Diego is comparing the solubility of 2 materials in a lab investigation. So here we have material A going into a beaker of water, and we're going to mix it up. I'm thinking about what we did in class. Here, another one, because we're comparing two materials. So here's another material, material B going in. We're going to mix it up, and we're going to see how these two things dissolve. So this is asking us about safe practices during the investigation. So which two things? Well, shorts, those don't really matter. Gloves, yes, we're mixing things we want to keep, especially if it's something hot. We want to keep our hands safe. A lab apron, I guess, maybe if we want to protect our clothes from any spill, since we're dealing with liquids and things like that. A hat doesn't really have anything to do with this. So everywhere I see hat, I'm going to put an X. So anything that has an X, I'm going to go ahead and take out. Safety goggles, yeah, that would be good. We're mixing things where we might splash something into our eyes, so that would be good. So gloves to protect our hands and safety goggles to protect our eyes are going to be the things that are going to help keep us safe. All right, question 3. All right. Elise wants to compare matter based on a physical property. Using the tools shown, how could she compare the objects? So this is a pan balance where you put an object on. So for example, if the object is heavier, then it's going to go down, and if something is lighter, then it would stay up in the air. So this is going to, it says, how could she compare the objects? So if she's comparing matter based on a physical property, I know this tool has nothing to do with temperature. This tool is not going to help me to see if something sinks or floats. Same thing, like volume, the space that something takes up. If I just put an object on this tray, I'm not going to be able to tell and compare. Like, that's not what this tool's for. It's to check mass. So again, something with more mass would go down, and something with less mass would stay up higher. All right, a company collects cans to recycle, and some of the cans are made of aluminum. So here's a can made out of aluminum, and then others are made from steel. What physical property could be used to separate and compare the different types of cans? So the cans, I'm thinking like cans like soda cans. I'm going to assume that those are the same size and shape, and I'm thinking about the information that they gave me. So the big clues are that some of them are aluminum and some of them are steel. And so that doesn't really connect with size, or it doesn't connect with size, it doesn't connect with shape, and it doesn't connect with, like, both of these are not able to be dissolved. There's no, like, they're not soluble, so it doesn't have anything to do with solubility. And so the only thing that it connects to is magnetism, because I know that I could separate these things, because again, that's my job. I'm trying to separate them and compare them. So if I use a magnet, I can tell, okay, some of these are magnetic and some of these are not magnetic, and that would help me to be able to separate these two things. So looking at the clues they gave me, knowing that some are aluminum and are not going to be magnetic, and some are steel and are going to be magnetic, that's going to help me be able to get that separated to compare them. All right, we have 4 samples, A, B, C, D, and Sonal's testing them. She's testing their properties, and she's recording the results. So spend some time looking at the table. We've got the physical state, so whether something is solid, liquid, or gas. We have something, each material has to do with whether it's soluble or not, whether it's going to dissolve in water or not. So some of them do, some of them don't. None of them are floating. and only 2 of them are conducting electricity and 2 of them are not. So I just made a little diagram down here just thinking about each of these materials. So A is solid. It's not soluble, so it's not going to dissolve, so I can see it. And it's not floating, so it's down here, it probably sank. And whenever I think of conducting electricity, I always think about, like, if I connect this to a circuit, is the light bulb going to turn on? This case, this object would. Then same thing I did for B, C, and D. So that's all here. And the reason I didn't draw anything in these beakers is just because it said that yes, these things are soluble. So they just, whatever it is, whatever liquid and solid are in B and C, it got dissolved and I can no longer see it. Material D is a liquid that didn't float and didn't dissolve, so I can see it, and it also turned the light on. So now I'm going to come over here, and it says, based on the data in the table, which conclusion can we make? And so I made the conclusion that material A, the one that I am most certain about, is A, because metal is solid. Metal, if I put metal in water and I stir it up, it's not going to dissolve. It's not going to float. And yes, it's going to conduct electricity. If I attach it to a circuit, it's going to turn the light bulb on. Some of these, like people put C, material C is a salt. So let's go through C. So salt is a solid, yes. Salt does dissolve. It does not float. And it does not conduct electricity. However, what about sugar? Sugar is a solid. Sugar will dissolve. It doesn't float. And it doesn't conduct electricity. So for C, it's yes, it could be salt, but it's not saying that it could be, it's saying that it is. So when we're making conclusions, we have to go by what's given to us. And if something else, like if they're saying, yes, it's that, well, I need more things in my table to help me to be able to say, yes, 100% it's salt. All right, last one here. Josh wants to compare 4 different objects. So we have these 4 objects down here. We have a copper washer, a plastic ball, a sheet of paper, and a rock. And it says he tests the objects by placing them in a beaker of water to see if it will float. He also tests the objects to see if they insulate heat and if they conduct electricity. So here they gave us the image, but they didn't do it in the beaker. So I went ahead and drew it out. And I put whether something sank or whether it floated. I put whether it was this column right here or row going across is talking about whether it's an insulator or not, or a conductor. And then here, this one down here, whether or not, again, if I hook it up to that circuit, is it going to turn the light bulb on? So here, I went through those, and then I looked in my chart, and I started with the ones like floating in water. There was only one thing that floated in water. So the thing that floated in water, when I come down here, is this plastic ball. So I know that material 3, because that was the only thing that floated, I know that material 3 is going to be the plastic ball. And then again, I came over here and I noticed no, yes. There was only one thing that conducted electrical energy. And down here, when my notes, I noticed that material, this copper washer was the only thing that was going to do that. So I know that material 4 is the copper washer. Then for material 1 and 2, so I'm done with 3, I'm done with 4. So these are both no's. These are both no's, so they both are not going to turn the light on in the circuit. They're both not going to float. Over here, if I notice these here, this is where the difference is. So one of them is an insulator and one of them is not. So material 1 is going to insulate thermal energy. So the only thing, so I'm done with copper washer. I'm done with plastic ball. So it's between the sheet of paper and the rock. So the paper is the insulator, so that's going to be 1. And then the rock, let me just verify. No, it does not insulate. No, it does not float. And no, it does not conduct electrical energy. So on each of these, I can take them, if I want to make sure that my answer is correct, I can go back. So material 1, I'm going to go straight across and I'm going to make sure that it meets all these criteria. Yes, it insulates thermal energy. No, it does not float in water. And no, it does not conduct electrical energy. Over here, I can go each one and check and verify that those are correct. Alrighty. Thank you for watching.